Today we're going to continue with the calculus review. So it's going to be 4-1. We're going to take a look at the 6 trig ratios. So we're going to state and use those 6 trig ratios and revisit the unit circle and how to evaluate trig ratios. Now in geometry, we gave the names to sides of a triangle from one of the 2 acute angles of a right triangle. So if I were to say that this is my angle that I'm referencing, we'll say it's angle theta. This is the adjacent leg, this is the opposite leg, and that is going to be a hypotenuse. And so depending on what this angle is, those 2 legs will be either the adjacent or the hypotenuse. If I use this angle, then this is the opposite, and this would be the adjacent. And then this is always the hypotenuse. And so using these labels, we came up with 6 basic trig ratios, and each ratio compares 2 sides to each other. So in this example here, I could compare the opposite to my adjacent, or the adjacent to my hypotenuse, or the opposite to my adjacent. And then I could also look at, the reverse direction of those. So instead of opposite to hypotenuse, I can do hypotenuse to opposite. And because I'm saying opposite 5 to adjacent 12, and then hypotenuse 13, I could say opposite to hypotenuse was 5 over 13, adjacent to hypotenuse is 12 over 13, etc. And I can go through and I can create these ratios. Now the names, this is our sine ratio, this is our cosine ratio, this is our tangent ratio, cosecant, secant, and cotangent ratios. And this is where in trig, so this is something you may have to go back and watch, we memorized SOHCAHTOA for these. The sine is opposite to the hypotenuse, adjacent to the hypotenuse, opposite to the adjacent. And then cosecant was the reciprocal of sine, secant was the reciprocal of cosine, and cotangent is the reciprocal of tangent. Reciprocal means they're flipped. So notice, see, those ratios are flipped. So just to practice a few of these real quick, we need to make sure if we're going to find all of the, if it wants us to find the ratio, okay, we need to know all the sides. You have to use the Pythagorean theorem to find the missing sides. But in this instance, it says find sine of theta, so that's the ratio of opposite to the hypotenuse. And so that's going to be 20 over 29. The next one, cosine of p. Well, notice I know that cosine is adjacent to the hypotenuse. Well, I don't have the hypotenuse, so I have to use the Pythagorean theorem. And so if I did 8 squared plus 15 squared, that would end up being, if I were to solve it, that would give me the 17. And so going through the Pythagorean theorem and solving for the hypotenuse, the missing value c, right, because I don't have that c, then I would be able to say it's adjacent over hypotenuse, which is going to be 15 over 17. So now we can also take this idea of our 6 trig ratios and we can also relate it to the Cartesian plane. And so we imagine from the origin, we take some value, our radius that's being extended out, and then we rotate it. Now when we rotate it, we can create a right triangle that's perpendicular to the x-axis. And this right here is going to be a reference angle. Now, going into the details of all this, if you forgot, you might want to take a look at the pre-calculus videos when it talks about this in coordinate trigonometry, and we lay that more in detail. But essentially, the x value, and this is my y value, and then we have our r, I can sit there once again and I can say, well, the sine from whatever angle, okay, is opposite to the hypotenuse. And then cosine's adjacent to the hypotenuse. Tangent's opposite over adjacent. And then I have my reciprocals. And then to find r, it's just the Pythagorean theorem, a squared plus b squared equals my r squared. And then you square root both sides, and then you'd get this formula right here. Now the point of this is, notice your sine value relates to y. Your cosine value relates to x. Now going into this here, let's say if I had a point, well, we got to plot this point, so it's 4, 1, 2, 3, 4, and 3. We can construct my triangle here. Now just remember, it's always perpendicular to the x-axis. If you need to draw that in there to help you, do it. So the x distance is 4, the y distance is 3. Now I could use the Pythagorean theorem to find my radius. So 3 squared plus 4 squared equals my radius. Square root both sides, so you're going to get r equals 5. And then I could use SOHCAHTOA to find all the 6 trig ratios. So the sine of theta, opposite over hypotenuse. If this is the angle, opposite to the hypotenuse. My cosine is adjacent to the hypotenuse. The tangent is going to be opposite over adjacent. Now I can go through and I can find cosecant, it's just the reciprocal, secant, it's just the reciprocal, and cotangent is just the reciprocal. Now, creating these triangles and drawing these in our Cartesian plane, there was these special ratios, and it was the 30, 60, 90 triangle and the 45, 45, 90 triangle. We took all the combinations of these triangles and being able to place them inside this circle, okay, but we place them basically on the Cartesian plane. It gives us what we call the unit circle. And these are all the values in quadrant 1 and quadrant 2 and quadrant 3 and quadrant 4. And it created like this nice pattern for us. If you notice, 1/2 root 2 over 2, root 3 over 2, root 3 over 2, root 2 over 2, 1/2. There's a pattern that goes on here. Now, in pre-calculus, we went through and we memorized the unit circle. So once again, you may have to go back through and watch a few of the other videos to be able to do that. I'll have them linked, and it goes a little bit more further with the unit circle. I'm just going to go into how to interpret the unit circle and not necessarily how to memorize it. So for example, if it says find the cosine of 135 degrees, remember I said cosine relates to x, and then the sine value related to y. So cosine of 135, I go to where it says 135 degrees, it's going to be my x value, and so it's going to be negative root 2 over 2. The sine of 270 degrees, you go to 270 degrees, your sine value, that's going to be negative 1. Cosecant of 7 pi 6, I know cosecant relates to sine, and sine relates to y. So I go to 7 pi 6, I find what my sine value is, which is negative 1/2. So I'll reference that, negative 1/2, but cosecant was the reciprocal, so I need to flip it, and so I get negative 2. Let's try that again, but let's look at secant. I know that secant relates to cosine related to x. So at 5 pi thirds, which is right here, my x value is 1/2, that's my cosine, so I'll just put a little reference note there. But the secant is the reciprocal, so I need to flip it. To find tangent or cotangent, we just stated that tangent is y over x, or sine over cosine. So what we're going to have to do now is we're going to add like tangent 360, which happens to be here because I did one full revolution. So this is also 360 degrees. We need to do sine over cosine. Well, my sine value is 0 over my cosine value, which is 1, and so I get 0. At cotangent of negative 30 degrees, cotangent is cosine over sine, and then the negative means we go negative rotation, so that rotating that way is negative, so I'm rotating that way 30 degrees, and so x over y, those cancel out, and so I get negative root 3. So let's close today's lesson. What was reviewed today? Well, we introduced the 6 basic trig ratios. We looked and briefly examined how they interact on the coordinate plane, and then we examined the unit circle. So I want to hear back from you. What is a sine ratio? So tell me how the sides of a right triangle and how they relate, and then tell me how sine and cosine relate to the Cartesian plane, meaning like how does it relate in terms of a point. So this does conclude our lesson. If you have any other questions, please leave them in the comments.